Thank you very much. Can people hear me with the remote mic I've got? Okay, good. Well, first I'd like to thank the organizers for inviting me and putting together such a great, really comprehensive program. People from all over the place coming in to talk, so pretty exciting. So I'm going to be doing sort of a bit of an overview of some of the good news and bad news, challenges and opportunities that climate change means for the dairy industry, and going into some specifics on crop production in particular. And my colleague Larry Chase is going to be following, talking a little bit more in detail about animal production. And we'll be hearing more about this stuff all day. First, I want to point out just a couple of websites if you haven't already been introduced to them. There's Cornell's climate change website, simply climatechange.cornell.edu. If you go to resources there and look up agriculture, you'll see fact sheets and stuff relevant to that. And then our new Climate Change and Agriculture Institute has its own website as well, climateinstitute.cals.cornell.edu. And both places have a lot of good resources. My slides are actually in the booklet you've got, so you'll be able to look this stuff up. So kind of in broad brushstrokes, what I'll be covering in a little more detail in my following slides are some of these types of challenges and opportunities. And I guess let me start with the opportunities first of all. While we will have new heat stress challenges, they're going to be less severe than many competing regions. So a lot of climate change adaptation has to be, of course, also looking at what's happening to our competitors. Another opportunity is relative to other regions, we have water, sometimes too much. I'll be talking about how even with the projected rainfall patterns and what we've been seeing here in the recent past, we still are likely to have an increase in the frequency of short-term summer droughts. But again, relative to many other competing regions, we have water. Longer frost-free periods allows exploring higher-yielding crop varieties, double cropping, and we're near to markets. 22% of the U.S. population lives in this northeastern part of the U.S., so that's kind of the Northeast story on this. Some of the challenges, although we're not going to be as bad off as some other areas, there's no question that one of the things we have the highest degree of certainty about is we're going to have an increase in the frequency of high temperature stress. That's bad for crops and bad for milk production. We've got kind of a dual whammy in terms of water that we'll be facing. Farmers are going to have more challenges with water management than they've had in the past, both too much and too little water for crops, and less predictable. A lot of increases in changing pest, disease, and weed dynamics that farmers have to deal with that they've never really had to deal with before. Previous generations of farmers will not, they didn't have to face the kind of rapid shifts we'll be seeing in the future. And climate change, as I'll point out in a couple of my slides, is much more complicated than just warming. So some of these, I've got a few climate slides, and some of these are De Gaetano or others may have seen them yesterday. This is just showing kind of the average over various decades going all the way back to the 1870s, the number of days of heat stress, and the number of days with greater than 2 inches of rain in a 48-hour period. And you can see in the last decade, we've had a gradual increase in trend of both of these things, heat stress and heavy rainfall events, more of the rain we do get coming in heavy precipitation. But it's becoming more dramatic, particularly in the last decade. And both of these phenomena are things that are being experienced across the northern hemisphere and that the climate models predict will be continuing to be a challenge for us even more as we go forward in the coming decades. This is the dairy heat stress chart, which is probably familiar to most of you. It's been around well before we were concerned about climate change, simply for maintaining animals healthy and productive in their facilities or outside or wherever they may be. This is really built around this thermal heat index model. A THI, thermal heat index of above 72, is where you begin to have some negative effects on milk production. And while you have to get up to really severe high temperatures to have animal mortality and that sort of thing, dairy cows like it really cool, and it doesn't take much, even temperatures in the upper 70s and 50% or higher relative humidity, and you begin to impact milk production. So that's the kind of thing that's going to be, in the short term in particular, a challenge for dairy managers is reducing that and controlling that as much as possible with some strategies. This is using that thermal heat index simple model we have. This is something we did with Larry Chase, who will be my colleague, will be our next speaker. Across the top panel is the business as usual, as they call it, fossil fuel emissions scenario as we go through this century, looking at the month of July. And basically the orange areas are the areas where we're getting consistent monthly average values of THI in this reduced milk production zone. So showing that if we continue as we have been in terms of in the future with the pace of continued energy use in the form of fossil fuels, we'll be ending up with a lot more of those kind of challenges. Of course, this is a very simple analysis, assuming no particular farmer adaptations to all of this. I wanted to talk a little bit about crops and what this all might mean for feed supply. And this is an area of climate change where we have actually quite a bit of uncertainty. Some of the things I've mentioned so far, we have a fair amount of certainty about. We know we're going to get an increase in heat stress in the coming years and this increased frequency of high rainfall events. But what's it all going to mean for crops? Actually, yields may increase, prices may decrease due to longer growing season varieties being used. So that's an opportunity for us. Or yields may decline and prices increase due to crop losses associated with heat stress, drought, and heavy rainfall events. Increased use of corn biomass as renewable energy, while this is a very positive thing in some ways, could also obviously have an impact on feed supply and feed costs. Really, these combined uncertainties make it difficult to predict the potential effect of climate change on the dairy industry from this angle in terms of growing our own silage or purchasing it elsewhere. So it really just means that farmers of this generation, unlike previous generations in this area, really have to be looking at what's happening to rainfall patterns and what's happening to feed availability and prices and monitoring all these factors and being better prepared to adapt. Exploring longer growing season corn varieties. Now, this is one of our biggest opportunities, I think. We've already we've already observed over a week increase in our frost-free period in the Northeast. And actually throughout the country, we're seeing this sort of phenomenon. So this means farmers can begin exploring longer growing season varieties, which are out there photosynthesizing more and, of course, can have higher yields. So this is something that farmers should be taking seriously and looking at this as an opportunity. Of course, what we found is, as I said earlier, climate change is complicated. It's not just about warming. We've seen some years where we've had, indeed, almost record-breaking longer frost-free period, but it's been one of the shortest growing seasons for people growing corn that they can remember in recent history because they couldn't get in to plant until mid-June or whatever. So if we're having heavy rains during the planting season, side dress, or harvest period, this can obviously constrain our growing season variety selection that we might use. We've talked to some dairy farmers in the Northeast who talk about in past generations, it was a very narrowly confined varietal selection that they used, just differing by a few days in terms of the growing season length. And now they grow shorter growing season varieties than they ever grew for years like this where they can't get into plant, and longer growing season varieties, and really diversifying their operation in that way, which is really a smart adaptation to this unpredictability. This thing about wet conditions and rainfall, this is showing a map of the U.S., and again, I think you may have seen this previously, but it shows, this isn't talking about increases in total rainfall, this is talking about the increase in the number of days where you have heavy rainfall events. So the rain that when it does come, it's coming down in heavier rainfall events. We see that even in the desert Southwest, there's a slight increase in the frequency of high rainfall events. But across the U.S., the Northeast is the real winner here. A 71% increase since the 1970s or so. I think this went back to this 1958 in the frequency, the number of days where we're getting this heavy rainfall. So that's something farmers are kind of feeling in the short term here. The longer frost-free period, while it's a good thing in terms of crop variety selection and opportunities there, that longer frost-free period reflects also warmer winters, and that has implications for particularly insect pests, which are cold-blooded animals and respond very much to temperature really dictates their habitable range. And the same is true for many of our aggressive weed species, that the range in which they can do well and be productive is very dependent on the temperature. And so things like the little flea beetle, which doesn't do perhaps that much direct crop damage, but as most of you know, is the vector for Stewart's wilt of corn, the corn earworm. These are both some pests in the Northeast that historically have been constrained because of our cold winters, killed back in the winter. But with warmer winters, they're more pervasive and showing up earlier. And anybody from the South will recognize that weed kudzu. We projected some years ago that it would be coming into the Northeast, and indeed my colleague Lou Ziska at USDA Beltsville has documented kudzu getting into New York, for example, as its growing season range, as we're having warmer years, and it's able to overwinter better than in the past. So farmers are going to be responding by having to monitor better. There's, of course, the potential for increased chemical loads to our environment with this, and so we need to be proactive and be looking at alternatives to chemicals so we're not having to overload our crops and our land areas with chemicals to deal with this, adapt to this aspect of climate change. But we just need to look south of here to see what kind of, to some extent, what type of changes we might see. This is the graph on the left is showing the kind of the range of the annual temperature projections going up to 2100, and this is particularly for the southern tier of New York. And you can see we're looking at anywhere from the average annual temperature starting at today's annual about 48, going up 4 to 6, even more, 8, 11 days Fahrenheit, depending on which model we use. But that gray area there in the middle kind of shows you a fairly significant temperature increase. All the models generally are predicting some level of increase. What's important to note is that when you look at annual rainfall, of course the error bars are bigger around rainfall. It's harder for the climate scientists to predict rainfall patterns. But the models generally, if you were to, the best we can do in terms of speculating from that is we might have little to very modest changes in rainfall unless you look at the very extreme high model or the very extreme low model, but possibly little change in rainfall. But if we have warmer temperatures, significantly warmer temperatures, and the same amount of rainfall in the summer, that actually means more summer drought because the crops will be requiring more water, particularly with longer growing seasons and warmer temperatures. And if the rainfall doesn't concomitantly increase to keep up with that, we will have more summer drought. So actually our projections of summer drought for the region increase as well as our projections of increased frequency of high rainfall events. Just to give you a little another perspective on this drought issue, this is actually the historical data for western New York, Rochester, New York. And the blue line across kind of horizontal all the way across from January, month 1, summer is month 6, 7, 8, of course. The blue line, what's interesting about this part of the country is precipitation, whether it be snow or rain, is pretty steady between 2, 3 inches a month, roughly. But of course, crops in the middle of summer actually need more like an inch per week, which would be 4 inches per month. So you can see even in our historical pattern for Rochester, New York, there are summer water shortfalls. The red line represents the potential evapotranspiration, the water demand by a full canopy crop. Now, of course, some of that summer water deficit can be taken care of if the soil is deep enough, roots are deep enough, and you have good water holding capacity. But what we expect in the future is that the potential evapotranspiration is going to go up, and rainfall might stay the same, so it's going to increase those summer water deficits even more. So putting this together, the risk of heat stress, summer drought, and heavy rains, all projected to increase for the Northeast. It's going to affect crop yield and quality if farmers aren't on top of this and do something about it, and heat stress and livestock. In terms of farm level adaptation at the farmer level, what can be done to build resilience to climate change? In terms of animal management, Larry, who will be following me, will be talking more about some of this and other speakers today. But obviously, you don't want to build a barn today on yesteryear's heat specs, summer heat specs, and improving barn ventilation and cooling capacity is probably something farmers are going to need to be thinking about if they don't already have pretty good cooling capacity. Minimizing heat exposure of animals, increasing water availability, and adjustments in the diet. In terms of the crop, soil, and water management, really this thing of diversification is what we see a lot of farmers already doing, almost intuitively, even if they don't recognize it as a climate change response. But beginning to recognize that the weather patterns are a lot different than what their parents and grandparents saw, and they're simply, to hedge their bets, they're doing more diversified system, whether that's a more bigger range of growing season type of varieties, different planting dates, etc. So looking at new crops and new varieties, integrated pest management is more important today than it ever was because we really need to be monitoring these changes, and changes will be coming, and farmers have to be much more on top of it than even in the past. Another topic that's very near and dear to me, since I'm also very involved in our Cornell soil health program, is improving our soils, maintaining water holding capacity and good drainage of our soils with good soil health management is pretty key to farmer level adjustment. And then in some cases, actually irrigation and drainage systems may be considered depending, of course, on the crop and the system. So farmers are going to need new climate-based decision tools for strategic adaptation. One problem for farmers, it's the same problem even the professional climate scientists face. Is this, quote, normal wacky weather, or is this actually part of a climate change phenomenon, a change and a direction, a trend that's here to stay, and it's time to invest in something? Invest in a new drainage system, an irrigation system, renovating the barn ventilation system. And when do you do those things? And this is what our Cornell Institute for Climate Change and Agriculture, a big focus of that new institute is providing tools for helping farmers make those kinds of strategic adaptation decisions. One thing we worry a lot about is financial barriers, and whether, not all farmers have the same access to information, not all of them have the same access to capital. So there may be some fairly straightforward adaptations a farmer might be considering. It might make a lot of sense, but if they can't get the loan from the bank to make those kinds of adjustments, they could really be out of luck, which could lead to even more consolidation of our dairy industry, a lot of small family farms having to leave the business. In terms of support beyond the farm, things like what universities can do, government policy people, non-government organizations, industry. One thing is financial assistance for adaptation investments. There's various things we might think about in terms of strategies to help farmers adapt, low-cost loans, etc. The new decision tools I already mentioned. Real-time weather risk delivery systems so farmers get a better handle on what's coming their way. I mentioned IPM. Rapid response planning for extreme weather events, crop insurance programs that provide a safety net, yet encourage adaptation. Land use and climate change policies that integrate economic, environmental, and equity issues. And of course, things like what Cornell scientists are working on, developing new crop and livestock options in management. Finally, I want to say just a few words on the mitigation end. What I've kind of focused on so far is what I call adaptation, kind of coping with some inevitable climate change, taking advantage of opportunities. But I also want to talk about the energy end and the greenhouse gas management end. And really, most farmers I know care a heck of a lot about energy prices and energy costs and energy efficiency. Farmers went to diesel engines decades ago because of the energy efficiency. Farmers are always interested in renewable energy options such as wind turbines if they make sense economically, and I think policies that can encourage that renewable energy on the farm are very positive. Biomass fuel crops, this is really recycling carbon instead of bringing carbon from deep in the earth. It's been out of our climate system for millions of years, and putting it up into the air by burning fossil fuels using biofuel crops makes a lot of sense. But of course, it does depend on what you grow, when you grow it, and where you grow it, and how you grow it. So if you use a lot of fossil fuels to grow the crop, that's not really solving the problem. But there's a real potential there. I like to show this when I go to Washington, D.C. and talk and see what people see. What I see is economic opportunity. to address the energy waste management challenge that farmers have to face. Recoupling animal and crop production systems to recycle the nitrogen, carbon, and energy that's in that cow pie there. I mentioned soil health already. So this is, the things we've been talking about with our soil health for many years is all about focus on crop production and maintaining yields, minimizing inputs, et cetera. But it's also a climate change adaptation and mitigation strategy. It's an adaptation strategy, rebuilding organic matter in soils by reducing tillage, using cover crops, manures, and compost. This increases water holding capacity and drainage. So increases resilience to short-term droughts and flooding, which could be more common. At the same time, that carbon that's in that organic matter is carbon that's now in your soil, doing you good, instead of in the air as carbon dioxide, the greenhouse gas, not doing you good. An important point to keep in mind, and you may be familiar with this, but in case not, when we do the analysis, the pie chart for U.S. agriculture greenhouse gas emissions, and we do it on a so-called CO2 equivalent basis, it's not the carbon dioxide emissions that are sort of the culprit, like tractor driving and that sort of thing. Not even the methane emissions. Nitrous oxide actually turns out to be the winner, and that's because it's about 300 times more potent on a molecule per molecule basis than carbon dioxide in terms of its global warming potential. So when we do it on the CO2 equivalent basis, nitrous oxide emissions are very much the story, and that really gets down to nitrogen management. This, I don't have too much time left, so I'm going to go into this one in a lot of detail, but this just shows an analysis from an Ontario dairy farm looking at the CO2, nitrous oxide, methane emissions from various aspects of the operation. And if you look at the very bottom line there, you can see that even on this a dairy operation, nitrous oxide emissions accounted for 55% of the emissions. And as I say, most of this had to do with nitrogen fertilizer additions to the crop system. Now, this can be both organic or inorganic nitrogen. It could be manures, et cetera, or it could be synthetic nitrogen fertilizers. The distinction between those two is not so much in the nitrous oxide emissions, but in the when you're using synthetic nitrogen fertilizers, there's also a carbon footprint associated with the manufacture of those. So that's something to keep in mind. And there's an interesting poster, a couple of posters here about nitrous oxide emissions and organic and inorganic nitrogen. It gets into some of the details I suggest you look at. Karine Ketterings and her grad students have been working on that. Using legume nitrogen instead of fertilizer nitrogen in rotations is a way of getting away from use of reliance on synthetic nitrogen fertilizers, again, reducing that carbon footprint, and also good for the soil because the organic matter, in addition to the nitrogen that legume crops bring, helps build the soil health. Here at Cornell, you'll be hearing more later today, I think late today, on Adaptin, which has recently been commercialized. My colleagues Harold Ness and Jeff Melkonian have been working on this for some years. I've been somewhat involved, but it's a weather-based, uses real-time weather data to predict basically one important thing is how much, quote, free nitrogen you're getting from the soil microbial activity. So based on soil temperatures and moisture, it tells you how quickly the soil microbes are making nitrogen in the soil available to your crop, can help you reduce side dress rates. And it's proven itself many times over, which is why it's now becoming commercial and available in 26 states. So this is my last slide, just kind of bringing home the message that farming success in a changing climate, really being prepared about this makes good business sense. Taking advantage of any changing market opportunities, making these strategic decisions regarding capital investments, particularly those capital investments that happen only every once in a while but are quite expensive and long-term. Things like barn design, retrofitting a barn, new drainage or irrigation systems, things about herd size, site selection, these sorts of decisions that really have long-term consequences. Very important to know what's happening where you are in terms of climate change projections and recent weather trends. Anticipating the new weed, disease, insect pests. And of course, we want to avoid unintended consequences like increased chemical loads to waterways, undesirable land use change and degradation. I think farmers can do themselves a lot of good by talking to their congresspeople, whether they be state level or national level, to help them support farmer needs for adaptation and mitigation. Get the policies working your way in terms of what works, what will really benefit farmers and food security for the country. I think this energy thing and greenhouse gas management is really, I mean, from the farmer's standpoint, I see that really as where does it hit my bottom line? How can I increase profits in terms of thinking about better energy efficiency on the farm and knowledge about energy policy incentive programs that are out there. And finally, you know, in the big picture, I go to some meetings where we're really talking about the national interests, and all this climate change thing is very important from these standpoints. Our whole ag economy, food prices, not only in this country but worldwide, and food security. So with that, I'll stop. Thank you.